We travel back in time to 4.6 billion years ago to see the moment when our solar system was born. Wow, there's nothing that looks like a star or a planet. So far, there's just a giant cloud of dust. It's called a nebula. These are molecules of hydrogen in heavier elements, along with ice, left there from a previous star. But this cloud isn't dense, so it can't turn into a star or a planet. But then a blast wave comes here, maybe even several. There's a supernova explosion a couple of light years away from our nebula. This is when a giant star burns off its fuel, then collapses under its own weight. At this point, a boom of such force that its light can be seen dozens of light years away. The blast wave from a supernova reaches our nebula like a sea wave. It hits the dust cloud, causing it to shrink and become denser. Then the nebula gained a common center of gravity. It attracted more and more dust particles to itself. This put a lot of pressure on the nebula's core. It started spinning. And the greater the mass of the central cloud, the faster it rotated. The particles inside the core collided faster and more frequently. This raised the temperature of the nebula to several thousand degrees. At this point, a protostar appeared. It was a young and unstable sun. When the temperature in the nebula's core reached millions of degrees, nuclear reactions began there. The cores of light elements like hydrogen and helium hit each other and fused into heavier elements. Let there be light. 4.5 billion years ago, the protostar evolved into a stable sun, but 30% dimmer than we have it now. There's also a giant cloud of dust left behind. This is the remnant of material that didn't take part in the creation of our star. Now you can see the larger objects in this cloud. Heavy elements and dust began to pile up, forming protoplanets. At this stage of our solar system's existence, there were about 100 protoplanets, ranging in size from lunar to Martian. Back then, there was nothing but total chaos. These protoplanets didn't have clear orbits, and they began to collide with each other. Some crashed into a pile of debris, creating massive explosions. Others collided tangentially and simply changed their trajectory. In this cosmic billiards game, the largest protoplanets won. They literally ate the smaller debris and got bigger and bigger. The chaos didn't stop until about 100 million years later. You can see some nearly formed planets: Mercury, Venus, Earth, and Mars. Our home planet now looks more like a lump of lava. The constant bombardment of the surface by various asteroids has heated the planet greatly, but now it has begun to cool down. Everything went quite well until an unknown villain appeared on the horizon. It's Theia. It's a hypothetical planet the size of Mars, formed around the same time as the other planets. And now, it's spiraling toward Earth, ready to hit it. Bam! As a result of the impact, a huge chunk of our planet was knocked out into space. Theia herself was blown to pieces. Its core merged with the core of the Earth, while the rest of the material remained in our planet's orbit. Gradually, the debris from both planets began to collide with each other and merge into a large cosmic body. When the dust settled, the Earth received its satellite, the Moon. Another hypothesis for the formation of the Moon suggests that Theia was much larger than Earth. It only lightly scratched our planet and continued moving without losing its material. And the Moon was formed almost entirely from particles of our planet. As proof of this hypothesis, we have samples of lunar soil delivered by the astronauts of the Apollo mission. It turns out that the lunar soil is very similar in composition to Earth's crust, and it could only have gotten there as a result of some violent event. Gas giants like Jupiter, Saturn, Uranus, and Neptune formed a little later and further from the Sun. These planets are literally balls of gas. There's no solid surface. If you step on Jupiter, you'll fall until you reach its core. These guys couldn't get a solid surface for several reasons. They formed later when other planets took over the metals and silicates. They also all originated beyond the frost line. This is a hypothetical point somewhere beyond the orbit of Mars. The sun doesn't heat the area behind this line enough for water to be in a liquid state. So there was a tremendous amount of ice in the remaining clouds of gas. 3 million years after the birth of the sun, these building materials started to pile up and build mass, becoming Proto-Jupiter. Within a couple of million years, this ball of ice could reach a mass about 50 times larger than Earth. And the heavier it got, the more gas from the disk it was able to accumulate. In a short period of time, Jupiter absorbed almost all the material from the disk of gas near it and accumulated about 318 Earth masses. Jupiter had a very strong gravitational field, and it wreaked havoc on all objects in the area between Mars and Jupiter. Protoplanets collided there much more often, causing them to collapse. As a result, we have the asteroid belt. These are fragments unable to reassemble into a full planet because of the intense gravity of the gas giant. Saturn, the next of the 4 gas giants. It's 3 times smaller than Jupiter. It's thought to be so small because it's even farther from the Sun, about 10 Earth-Sun distances. And it began its formation even later when Jupiter left almost nothing of the gas disk. But Saturn got another distinguishing feature: the rings. They're so wide that you could fit 21 Earth planets on them, and they're as thick as a 5-story building. We still don't know how they were formed, but there's 2 main hypotheses. So Saturn has 82 moons discovered so far. There may have been one more, but it was destroyed in a wild collision. The moon was shattered into small fragments that began to orbit the gas giant. These fragments, in turn, collided with each other and shattered again. Gradually, debris the size of a skyscraper turned into small grains of sand. Yep, Saturn's rings are made up of cosmic dust and ice. Then come Uranus and Neptune. They are much smaller, only 14 and 17 Earth masses. It is believed that they couldn't reach the size and weight of Jupiter because of the strong solar wind. It gradually blew the gas disk outside the solar system into interstellar space. So there were much fewer building materials for new planets. When Uranus was formed, it experienced a catastrophic collision with another protoplanet, and probably a very large one. The collision caused Uranus to fall on its side. All planets have their axis of rotation pointing upward, but the axis of Uranus is pointing toward the Sun, so it looks more like a rolling ball. Only it's rotating retrograde. That means it's spinning against its own motion. It's like a car driving forward, but its wheels spinning counterclockwise. Behind the gas giants is the Kuiper Belt. This is the area beyond the orbit of Neptune. This is where the asteroids, dust, and ice were left after the solar system formation. It's similar to the asteroid belt between Mars and Jupiter, but it's about 100 times heavier. Knowing how our solar system was formed, let's see how it might be destroyed. The Sun has a lifespan, just like any other star. Right now, it's about halfway through its life cycle. Every second, the Sun turns 4 million tons of matter into solar radiation. Gradually, it'll run out of fuel and begin to burn heavier elements within it. This will increase the temperature, luminosity, and size of the star. In 1.1 billion years, the Sun will be 11% brighter than it is now. The seas and oceans on Earth will begin to evaporate, and our planet will heat up more and more. In 3.5 billion years, its brightness will be 40% higher than it is now. Conditions on Earth at that point will be similar to what we have on Venus now. Life will be simply impossible. In 7.8 billion years, the Sun will start burning hydrogen in its shell. This will cause it to expand and become a red giant. It'll be about 256 times larger. At that point, the star's outer shell will be exactly where the Earth's orbit is now, but it'll lose its mass. So there's a possibility that our planet will migrate a little further away from it. But it won't matter, because life on Earth won't be able to exist for several billion years already because of the high temperature, and a strong solar wind will simply blow our atmosphere away. Then the thermal pulsations inside the star will tear off the outer shell of the Sun. This shell will turn into a planetary nebula, almost exactly like what we saw at the beginning. And all that will be left of the Sun is a white dwarf, the size of the Earth, which will fade away for a few billion years.
I bet you're dreaming of traveling deep into space, but I'm just as sure you don't know even half of all those amazing things that are happening in our home solar system, like ice-spewing volcanoes on Pluto, a potential giant planet lurking on the outskirts of our solar system beyond Neptune, or a giant canyon the size of the United States on Mars. Let's have a look. First of all, let's travel closer to our Sun and see how insanely massive it is. Want some proof? Well, 99.86% of all the mass of the solar system is the mass of the Sun. In particular, hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. I live on one of those. Oh, and even though you might not have noticed it, we live inside the Sun. Wait, I didn't mean we're the inhabitants of the red-hot ball of light approximately 93 million miles away. No. The fact is that the Sun's atmosphere stretches far beyond its visible surface, and our planet is right within its reach. In fact, it's the gusts of solar winds from the Sun which create such breathtaking phenomenon as the northern and southern lights. Oh, and while speaking of the solar system, you must know that it's a whopping 4.6 billion years old. Scientists came to this conclusion after they studied the oldest material they could get. I mean, meteorites, of course. The solar system is also breathtakingly vast. You'd have to travel 11 billion miles away from Earth before leaving it. Wow, just think of the frequent flyer miles you'd get. Uranus rotates on its side, and astronomers have no idea how the planet chose such an unusual position. The culprits could be ancient mega-powerful collisions, but so far, it's just a theory. By the way, Uranus is the only planet sitting on its side. Its equator is nearly at a right angle to its orbit. The ocean on Jupiter is larger than any other on the rest of the solar system's planets. But wait, it's not the ocean you think about. The one on Jupiter isn't made of water. It contains metallic hydrogen, and its depth is a staggering 25,000 miles. This is actually almost the same as the circumference of Earth. Volcanoes on Earth are different from those on Pluto, like fire and ice. And I mean it literally. While we have scorching hot lava spilling volcanoes on our planet, volcanoes on Pluto spit ice. When frozen, water expands, and this enormous pressure builds up until one day, bang, the ice erupts. In the process, a new cryovolcano is formed. By the way, as you may remember, Pluto used to be a planet, but this title was taken away in 2006 by some astronomical bureaucrats. Later, Pluto was reclassified as a dwarf planet. But the most unexpected fact about this space body is that its diameter is smaller than that of the U.S. See for yourself. The greatest distance across the country, from Maine to Northern California, is about 2,700 miles. As for Pluto, it's only 1,470 miles across. Now, even if you're a tiny celestial body, you can still have a moon of your own. In 1993, the Galileo probe was traveling past a miniature asteroid that was no more than 20 miles across. Imagine astronomers' surprise when it discovered that the little thing had a 1-mile-wide moon. Since then, scientists have found tons of moons orbiting minor planets of our solar system. Jupiter's moon, Io, exists in eternal chaos due to hundreds of smoking volcanoes on its surface. If you decided to visit this place, you'd see the smoke from these volcanoes billowing up high into Io's atmosphere. At any given moment, here on Earth, you can stumble across a rock that once came from Mars. After scientists analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places all over our planet, they came to the shocking conclusion that lots of those have a Martian origin. In many sci-fi movies about space, the main character accidentally gets into an asteroid belt and has to try hard to get away from countless rocks that threaten to damage their spacecraft. Well, it's nothing like the real thing. The only asteroid belt astronomers know about is located between Mars and Jupiter. There are thousands of asteroids in this region, but they're so widely spaced that the chance of collision is almost zero. Now, beyond the orbit of Neptune, there's a mysterious Kuiper belt filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding from our sight a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed, or not. Unlike what most people believe, there's water all over the solar system. And someone should wipe it up, huh? For starters, it's a pretty common component of comets and asteroids. You can find water in the shallowed craters of the Moon and Mercury. Mars has some ice at its poles, too. The same goes for smaller members of the solar system, like dwarf planet Ceres or Saturn's moon Enceladus. Astronomers even suspect that Jupiter's moon Europa might have some life. Under its frozen and cracked surface, there's likely to be liquid water. Europa is smaller than Earth, but it may host a giant and deep ocean that could contain twice as much water as all the oceans on our planet combined. Now, you might know that Mercury is the smallest planet in our solar system. It's also very dense, the second densest after Earth. But this mini-planet is getting even smaller and denser. After the Messenger spacecraft did its first orbital mission at Mars and mapped the entire planet, astronomers found out that Mercury is very likely to be a tectonically active planet. On its surface, there are cliff-like landforms, also known as fault scarps. They're quite small, which makes scientists think that they appeared not so long ago. In other words, the planet might still be contracting. Now, look at these magnificent rings. You can say without any doubt that this planet is Saturn. People have known about its rings since the 1600s when the first telescopes were invented. But Saturn isn't that unique. Nowadays, we know that every planet in the outer solar system, Neptune, Uranus, Saturn, and Jupiter, has a system of rings. And since we've started talking about the planets of the outer solar system, let's have a look at Neptune. This ice giant is around 30 times as far from the Sun as our home planet, which means it gets less light and heat from our star. But the planet radiates a lot more heat than it's taking. If we compare Neptune to nearby Uranus, we'll see that even though Uranus is closer to the Sun, it emits almost the same amount of heat as Neptune. Astronomers haven't figured out why it happens yet. One of the most unusual moons in the outer solar system is Uranus's moon Miranda. It has craters, sharp ridges, and other bizarre disruptions on its surface. Such phenomena are usually the result of volcanic activity. But Miranda is way too small to generate such a large amount of heat on its own. Astronomers think that it might be the gravitational pull from Uranus that heats and contorts Miranda's surface. But so far, it's just a theory. And there's no truth to the story that Miranda has a brother moon, Lin-Manuel. Finally, our solar system isn't the only one in the Milky Way galaxy. Far from it. The galaxy we live in houses over 100 billion solar systems. And if it's just our galaxy alone, what can we say about the whole universe?
The sun's heat is beneath our feet. Scientists have figured out that Earth's core is actually as hot as the surface of the sun, around 10,800 degrees Fahrenheit. One of the reasons it's so incredibly hot down there is because Earth is still shedding heat from when it was created billions of years ago. Also, when an object as big as Mars slammed into the young Earth, it not only created the moon, according to one theory, but melted the surface of the planet. A lot of that extra heat is probably still stored inside the core. But there's no need to worry. The planet's core is harder for us to access than it is to probe the surface of Pluto. In fact, chances are we may never develop technology that could physically reach the core. There's no air on the moon. But then, how can it be rusting? Scientists have discovered the presence of hematite on the moon, and it's a kind of rust. A special NASA research instrument examined the light reflected off the moon's surface. It turned out that the composition of the satellite's poles was very different from the rest of it. The moon's surface is dotted with iron-rich rocks, but without oxygen and liquid water, rust can't appear. Solar winds add to the mystery. They bombard the moon with hydrogen, and hydrogen makes it much more difficult for hematite to form. Even though the moon doesn't have an atmosphere, it still has some trace amounts of oxygen. Its source is our planet's upper atmosphere. Earth also protects the moon from almost 100% of solar winds, although not all the time. And even though our natural satellite is bone dry, there might be water ice in the shadowed craters on its far side. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Mars has 2 moons, Phobos and Deimos. In the next 30 to 50 million years, Mars's gravitational forces will tear Phobos apart, and it will likely result in the formation of a ring around the planet. The Earth is the densest in the solar system. At the Earth's center, there's a core that takes up 15% of the planet's volume. It consists of 2 parts, the outer and the inner core. The inner core is a solid ball made of iron and nickel. Its radius is 760 miles, which makes 20% of the entire Earth's radius and 80% of the Moon's radius. The 1,500-mile thick outer core is liquid. It also consists of iron and nickel, but it's not under enough pressure to be solid. Mars houses the biggest volcano in the solar system. While everything seems to be calm on Mars nowadays, in the past, some sort of force caused enormous volcanoes to form and erupt. One of these volcanoes is Olympus Mons. It's 16 miles tall, which is the height of 3 Mount Everests, and 374 miles across, making it about the size of Arizona. The volcano grew to such a gargantuan size because of the weak gravity on Mars and the lack of tectonic plate movement. Gravity is not the same everywhere. The rocks, metals, and other minerals and substances that make up the planet are packed into the ground more tightly in certain places than in others. This has surprising consequences. Gravity varies slightly depending on where you are. You weigh 0.5% less standing at the equator than you do at the poles. In most cases, that's a difference of less than 1 pound. How high up you are also has an effect. So if you were at the top of Mount Everest, you'd also weigh slightly less. Just don't look down. Earth's toughest living thing is so small you can't see it. Water bears, also known as moss piglets, are cute little creatures with 8 legs and squashed up heads that are less than 1/100th of an inch in length. Despite their microscopic stature, they can basically survive anywhere. They prefer bits of wet moss or the bottom of a lake, but they won't complain if you put them somewhere really uncomfortable. They can endure extreme cold and incredible heat, and survive both huge pressure and high radiation. Some of the little bears once even managed to survive unprotected in outer space for 10 days without a problem. That is tough. They handle all these things by rolling up into a ball and hibernating, which reduces their need for oxygen and food. The Moon's gravity is about 17% of that on Earth. If you weighed 200 pounds on our home planet, on the Moon, your weight would decrease to a mere 34 pounds. You would also be able to carry stuff 6 times heavier than what you can carry on Earth. It would also be easier to walk on the Moon's surface, but it would be more dangerous too. Your feet, inside a heavy spacesuit, would sink into the lunar soil up to 6 inches deep. But let's imagine you decided to skip the tedious process of walking by leaping through the air. Then you'd likely lose control of your jumps in no time. Plus, the Moon's surface is littered with deep craters. It would be a tough feat to avoid all of them. You can see solar eclipses because even though the Moon is 400 times smaller than the Sun, it's also 400 times closer to Earth. So it's perfectly capable of obscuring the star. But in 50 million years, I won't be around then. The Moon won't be able to block the Sun completely because of the satellite's changing orbit. A full NASA spacesuit costs an unbelievable $12 million. Yeah, I can believe that. 70% of this hefty sum is for the control module and backpack. At the very center of Uranus, there's a rocky core, small, just half the Earth's mass. Compared to other planets, Uranus's core is rather cool, 9,000 degrees Fahrenheit. An ice mantle surrounds the solid core, and that's the largest portion of the planet, about 80%. It's also not the ice you might be thinking about. It's a hot, dense fluid made up of water, ammonia, ice, and methane. sometimes referred to as a water-ammonia ocean. Uranus's atmosphere is mostly hydrogen and helium, but it has its blue-green color because of methane gas that absorbs the red light. The ocean on Jupiter is larger than any other in the solar system, but unlike Earth's oceans, it's made not of water, but of metallic hydrogen. The ocean's depth is a mind-blowing 25,000 miles. That's almost the same as the distance around Earth. Venus is a champ when it comes to volcanoes. The planet has about 1,600 major ones, but none of them is known to erupt. There's a supermassive black hole 250 million light-years away from us. It hums the deepest sound ever detected from any object in the universe. It's 57 octaves lower than the middle C on your piano. That's 1 quadrillion times deeper than what we can hear. Mercury is a few billion years old. In 2016, scientists discovered some abnormalities on the planet's surface, showing that it's getting smaller. After more research, they found out that Mercury hadn't finished cooling down yet. There are planets that aren't bound to any star orbit and aimlessly wander through outer space. Among the most spectacular-looking space objects are pulsars. Pulsars are a type of neutron star. They shoot out some of their material almost at the speed of light. Regular pulsars spin at a reasonable speed, between 1/10 to 60 times per second. But millisecond pulsars can spin at an impressive 700 times a second, which is way too fast for the human eye to even process. As they spin, they emit a beam of radiation from their axis that looks like the light from a lighthouse. Astronomers can notice pulsars when they face Earth, since it looks like a light being shined on our planet. When the light shines elsewhere, the pulsar can't be seen. Our sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Saturn's rings are very thin compared to its size. If you had a scale model of the planet that was 3 feet wide, the rings would be 10,000 times thinner than a razor blade. Even though Venus is the hottest planet in our solar system, it still has snow. But not what you'd expect. It snows metals and rains acid. Not a great vacation spot.
Earth. Home. The third blue rock from the Sun. The only known planet where life can thrive. We have around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide, give or take. The perfect balance to support our respiration. The troposphere is the lowest and densest part of Earth's atmosphere, 5 to 9 miles thick. It's the part of the atmosphere that keeps changing our weather. For any life to exist, we would need this atmosphere and the same combination of gases to breathe. If all the planets in our solar system were combined to become a mega-Earth, then humans wouldn't have evolved the way we are today, and we'd have a very different planet. If we take the landscape of Mars, we'll only have solid land without large bodies of water. Earth is the only planet in our solar system with bodies of water. One of the first wonders to see will be Olympus Mons, the largest volcano in the solar system. It towers Mount Everest by a long shot at 78,000 feet above the ground. Velis Marineris is a group of canyons that make the Grand Canyon in the U.S. feel like a average one. This wonder stretches for almost 2,500 miles and goes more than 4 miles deep. On top of these epic terrains, there's plenty of other grand-scale locations on Mars that are way bigger than the ones on Earth. The planet might be as large as Jupiter. If the Earth were the size of a grape, then Jupiter would be the size of a basketball. We'd have the size of Jupiter and the rings of Saturn floating around us. The rings may seem like some large chunks of rock in the air, but they're actually ice particles and chunks of iced rocks. They range from the size of pebbles to car-sized ones. Saturn's rings are supported by the unique gravity in the region. With a lot of these ice rocks floating in the sky, there won't be much sunlight entering the planet, which means the planet will always be colder than usual. Not to mention the many moons it has. Our megaplanet could also have many moons circling above us, contributing to the tidal waves. Jupiter is known for the red spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. The people of Mega-Earth will settle far away from it. Mercury is a planet but looks like the Moon due to all the craters lying around. That's because of many asteroids and comets striking it over billions of years. But the landscape here mainly consists of mountains, highlands, cliffs, and valleys. The Caloris Basin is almost 1,000 miles wide. They believe it was formed by a comet. The deserts on Earth are mainly hot and consist of dunes of sand, but they also have flat plains and small hills. The largest desert in the world is the whole Antarctic continent. Mercury has no atmosphere to trap any heat, so it gets really hot when the sun is facing it and freezing cold when the planet turns away from it. On this combined mega-Earth, the desert will most likely have a similar landscape to that of Mercury. The animals living here will probably be something like giant scorpions and desert snakes that soak in some sun during the day and go out hunting at night. But the soaring day temperatures would melt anyone walking. And even though Mercury is the closest planet to the Sun, it's not the hottest. Venus has temperatures of nearly 900 degrees Fahrenheit. Scientists believe that the lands here are flat because of the extreme temperatures, but it's not all flat, with some volcanoes and highland areas. We can probably find this terrain and climate near the equator, since it's always hot there. Humans can't live there unless they build special domes to sustain life. But since the planet is now huge, not all its territory needs to be populated. Some areas will have the proper atmosphere for breathing, but some places might not have such luxuries. Over at the poles, the climate will most likely mimic Pluto's, even though it's not technically a planet anymore. In 2006, they officially declared it a dwarf planet, and it's even smaller than the Moon. There's not much known about this little mini floating rock, except that it's composed of around 70% rock and 30% ice. Scientists believe that a part of its surface is covered in frozen nitrogen, solid methane, and carbon dioxide. Since the megaplanet is huge, gravity might be quite strong here. Jupiter's gravity is enough to double your weight. Humans will most likely be really tall and mega-sized to match the big planet. Even the oceans will be huge. Our oceans will look like little lakes compared to what Mega-Earth has in store for us. Humans need something close to 24 hours in a single day. Our bodies adjusted to it quite well, but it wouldn't affect us too much if the day had a few extra hours or a few hours less. We can't live on any other planet without wearing the proper gear. We wouldn't last more than a few seconds in places like Jupiter, Neptune, and Saturn. It's possible to last as long as you can hold your breath on Mars. The atmosphere is thin and the gravity is similar to ours, but you might freeze. Even though it's a red planet, it's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and the sunset. Ancient civilizations wouldn't have been as diverse as they were on Earth, since the extreme terrains and conditions wouldn't have allowed for discovery and training. But eventually, as humans developed special technologies for certain areas, different cultures would emerge. Many animals would also evolve in specific and unique ways, but because of the planet's enormous size, isolation, and being on top of the food chain would let certain animals be around since the beginning of the planet without evolving. So it's possible that this mega-Earth might have ancient dinosaurs roaming around, and they'd be even bigger than the ones on Earth. And even though there's a high chance that some humans might be physically different than each other, there might even be more than one species of humans living on opposite ends of the planet. Because of the isolation, they evolved in their own ways according to their surroundings. Over the centuries, technological advancements would spread different cultures around, and we'd be more open to each other. Neanderthals and Homo sapiens once lived side by side and were considered as the two species of humans. Neanderthals were intelligent and used tools for hunting and drawing. Homo sapiens were survivors and wandered around to discover new land. There could be 2 dominant human species and other minor ones that live in certain areas on Mega-Earth. They'd be bigger, tougher, and faster than us. The ones who live by the trees would have elongated limbs to stretch out and swing from tree to tree. The ones that live in savannas will probably run really fast and have long legs for that. Countries and cities will be bigger than what we have on regular Earth. A country can be as big as Earth itself. The human population can reach tens of billions. Special transportation technology might be invented for people to travel from one continent to another. Covering those distances can take months or even years if using regular aircraft. High-speed trains that travel so fast over land and rocket-like planes going through the sky. Traveling through oceans will require extremely sturdy ships. Traveling through the Atlantic Ocean is already scary for many, so imagine going on a voyage across a body of water that's potentially 8 times the size of Earth. We're going to need a bigger boat. There'll be areas to avoid, like the red spot with its perpetual storms raging on. But the tourist industry might have some room for anyone who wants to see it. Living on such a huge planet is unlikely going to become a reality for most of us anytime soon. But scientists are already discussing moving to other planets to find a new home for humans.
An exoplanet is any planet inside our solar system. Some of them are free-floating. Those are called rogue planets. They move around the galactic center. Others orbit their host star, or 2. For the first time, astronomers discovered exoplanets in the 1990s. Since then, scientists have found thousands of them. And now, you can sneak a peek too. Spoiler alert, some exoplanets are pretty bizarre. Others resemble our home planet and could probably support life. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. This means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth. Another Earth-like planet, TOI 700d, is 100 light-years away from us in the constellation Dorado. It orbits a small and rather cool dwarf star that is about 40% of the mass and size of the Sun. Its surface temperature is half as high as that of our star. The outermost planet, which is the very TOI 700d, is almost the size of Earth. It also sits in the habitable zone of its parent star. No flares from TOI 700 reach the planet. This increases the chances of the exoplanet being habitable. This means it can potentially develop and maintain life. Scientists don't know for sure the exact conditions on the surface of the planet, but one of the computer simulations they've created shows a planet covered with an ocean. It has a very dense atmosphere dominated by carbon dioxide. Astronomers think a similar atmosphere surrounded Mars when it was a young planet. But another 3D model shows TOI 700d as an all-land, cloudless world. That's what our Earth would probably look like if it wasn't covered with oceans. Winds on TOI 700d move away from the night side of the planet and meet in the area that directly faces the star. There is an exoplanet that stands out among the rest because of its awesome magenta color. You can find this world in the Virgo constellation. The planet is called Gliese 504b. The distance between this planet and its parent star is 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists received proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptional strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. If you traveled 20,000 light-years away from Earth, you'd come close to a red dwarf in the Sagittarius constellation. Such stars are very cool and small. Quite far away from this cold star, there's a planet. The distance between this world and its host star is so great that the planet receives very little heat. It's one of the coldest planets ever detected. The average surface temperature on the planet is lower than negative 360 degrees Fahrenheit. That's why the entire planet is covered with a thick layer of ice. If you stepped onto its surface, you'd see nothing but glaciers, plains, and mountains of ice. And still, astronomers claim life might exist deep beneath the frozen surface. All because the core of the planet is likely to generate enough heat to melt some of its inner ice. In this case, there would be an enormous subsurface ocean, maybe even swarming with bizarre life forms on the planet. One of the oldest exoplanets we know about is PCR B162026b. It's about 12.7 billion years old. It's almost 3 times as old as Earth, which appeared 4.5 billion years ago. This also means that the Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white dwarf and a pulsar, making almost 100 revolutions per second. Sunrises on this planet must look awesome. I bet the next exoplanet isn't like any other you might have seen before. It's often called Super Saturn, or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those of Saturn. The bizarre world is 434 light-years away from Earth. It's the only planet we know about that has rings similar to Saturn's. If you moved J1407b to our solar system and replaced Saturn with it, its rings would look many times larger than a full moon. Astronomers have noticed a gap halfway through the planet's rings. The chances are high that an exomoon the size of Mars orbits the planet somewhere within this gap. If you lived on this moon, you'd have an awesome view every time you looked up into the sky. This exoplanet, called WASP-12b, munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. This is likely to be the main reason for the insane temperatures on the surface of the planet. They can rise up to 4,600 degrees Fahrenheit. It's almost half as hot as the surface of the Sun. WASP 12b travels so close to its host star that it needs just one day to complete one orbit. Its night side isn't as hot as the day side, a mere 2,200 degrees Fahrenheit. Because of this difference in temperature, water vapor and clouds gather above the surface of the planet. From time to time, swirls of material from the planet's superheated atmosphere spill onto its star. About 4,000 light-years away from Earth, there's an exoplanet that might be one enormous diamond. It's 5 times the size of our planet, but needs only 2 hours and 10 minutes to orbit its parent star. It's a pulsar rotating at a rate of 10,000 times a minute. The planet is denser than any other we've discovered so far. It consists mostly of carbon, which is so dense that astronomers think it might be crystalline. If it was true, it could mean that at least some part of the planet is diamond. On WASP 76b, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit smaller than Jupiter and located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between WASP 76b and its parent star is 10 times shorter than the distance between Mercury and the Sun. That's why the star and the huge planet are tidally locked. One side of WASP 76b always faces the star, and the other side is always pitch black. This bright blue exoplanet sits 62 years away from Earth. A bit larger than Jupiter, it looks calm and peaceful. Its blue color might remind you of our home planet. But this familiar appearance conceals the planet's horrifying nature. The beautiful hue comes from silicate atoms and particles that make up the atmosphere. But the wind speed on the planet can reach 5,400 miles per hour. That's 7 times the speed of sound. The temperature there can rise up to 1,600 degrees Fahrenheit. But this isn't the worst. In this bizarre world, it rains glass, sideways. So it's probably not the place where you'd like to spend your vacation.
We're traveling through space at the speed of light. The route from Earth to the Sun at that speed will take only 8 minutes, but it would take us about 35 years to reach our destination, which is, by the way, still very fast. By comparison, a conventional rocket would take about 600,000 years to make the journey. And here we are. It's a star system suspiciously very similar to our own. And our scientists suspect that life could exist here, just like on Earth. A red dwarf, 30% the size and weight of the Sun, lies at the heart of this star system. But these are the planets orbiting the star that interest us most. The first of these is L9859b. Its size is somewhere between Earth and Mars, but it's very light. It's only half the mass of Venus. But life is impossible on this rocky planet. It's too close to the star, and it's so hot, you'd burn a cake if you tried baking it on its surface. It's about 100 degrees higher than the maximum of your oven. The planet makes a complete circle around its host star in just 2 days, compared to 365 for Earth. And it gets 22 times more energy than we get from the Sun. So it's not only hot there, but there's a lot of dangerous radiation. The next planet is 2.8 million miles from its host star. That's 13 times closer than the distance from Mercury to the Sun. And it makes a complete revolution around the star in 3.7 days. But what's interesting is that the planet is 30% bigger than the Earth and twice as heavy. So it belongs to the class of super-Earth planets. Such planets can be rich in water ice, methane, and hydrogen. These are some of the elements that are necessary for life's existence. Many scientists believe that it's on such planets that extraterrestrial civilizations can live. But because of the great weight of the planet, it has a strong gravitational force. So these civilizations may not be able to fly into space because it's harder for them to get out of the gravitational trap of a super-Earth planet. However, life isn't possible here because the planet is still too close to the host star. And just like in our solar system, the two nearest planets are too hot. But the third planet looks more promising. L9859d. It's almost twice as heavy as the Earth and 50% bigger. Scientists have calculated that about a third of its mass could be water. For comparison, the mass of all water on Earth is only 0.02%. The presence of water is the main condition for the emergence of life. But we can only guess where the water might be. It could be on the surface, but high temperatures can turn large oceans into giant clouds of steam. But water can also be contained in the groundwater below the surface. Well, we can't know that for sure yet. Let's move on to the next planet in the star system. This newly discovered planet is of the Super Venus class, L9859e. It's a rocky planet 3 times the size of Earth. The Super Venus class means that the planet is heavy enough to have an atmosphere, but the conditions there are more like a greenhouse. Different gases fill the atmosphere there. Star rays pass through them to the planet's surface, reflect off it, and rise upward. But the dense gases don't let them leave the atmosphere, so the planet gets hotter and hotter. This is the greenhouse effect that we try so hard to avoid on Earth. On top of that, the stellar wind carries water vapor and other elements from the upper layers of the atmosphere into outer space. Life cannot exist on such a planet, nor could it ever originate, just like on Earth's twin sister, Venus. So far, all the planets we've looked at are outside the habitable zone of the host star. That's the sweet spot at a perfect distance from the star. Not too close so that the planet isn't too hot and the water there doesn't evaporate instantly. And not too far away, so that the planet doesn't look like a cold desert. And planets B, C, D, and E are too close to the host star. But there's another hypothetical planet F in this star system, located right in this sweet spot. This super-Earth candidate is 2.5 times heavier than our home planet. So we have hopes that it's a rocky world, just like the other planets in this star system. The weight of planet F is enough to have a dense atmosphere, and the temperature on its surface should be suitable for water to exist there in liquid form. The planet makes a complete circle around its host star in 23 days, which literally means it's New Year every 3 weeks. It isn't very likely, though, that there's a civilization there that celebrates it. Indeed, the very existence of this planet is very doubtful, because we still have no direct evidence. All the other planets have been discovered by the transit method. That's when we point our telescopes directly at a star and watch its brightness change. When there's a slight drop in the star's brightness, that's when a planet has passed between us and the star. Like this dot. We have a short period of time while the planet is in the background of the star to determine its size and speed. Sometimes we can observe such transits of Mercury and Venus on the solar disk. And there are at least 29 potentially habitable planets out there in distant space that can observe Earth in the same way. About 1,715 stars within a few hundred light years are perfectly located for it. Each star has planets around it, but only 29 of them are in the habitable zone. So there really could be life and an intelligent extraterrestrial civilization out there. If so, they could point their telescopes toward the sun and see a small dot pass across the solar disk. And they could have been making these observations for at least the last 5,000 years. So they could see how our civilization was born and how we evolved. Moreover, these planets are close enough to pick up our radio signals and even television broadcasts. But it works both ways. Radio signals travel through space at the speed of light. We mastered this technology about 100 years ago. So if there really is a civilization out there somewhere, we would pick up their signals too. But so far, it hasn't happened. So we have no proof of the existence of life on these planets. The discovery of a star system like L9859 is very important to us because we're always looking for life outside of our solar system. And super-Earth-class planets are even better suited for the origin of life than planet Earth itself. Such planets are sometimes called superhabitable. So some scientists think that Earth is a good place for life, but not the best. Super habitable planets would have to be 30% larger than Earth and twice as heavy. This would create stronger gravity, which would make the atmosphere on the planet denser and with a higher concentration of oxygen. This in turn would raise the average temperature on the planet to a perfect 77 degrees Fahrenheit, so plants would thrive there. Also, stronger gravity makes the surface of the planet flatter, so there might be more oceans there than on Earth. This would make aquatic life much more diverse. The host star also plays a very important role. It should be smaller than the Sun. The bigger the star, the more of its fuel it burns. This means that the lifespan of such stars is much shorter. For example, the lifespan of the Sun is about 10 billion years, but a red dwarf can live up to 30 billion years. More time, more opportunity for the birth of life and evolution. So far, scientists have discovered 24 superabundant planets, but that still doesn't mean that there is life there for real. But some scientists believe that there are already at least 36 advanced civilizations in our galaxy, besides Earth. They've searched for similar worlds on the star map. First, we find stars that look like the Sun among about 100 billion stars throughout the galaxy. Now we choose from them those that are rich in iron. Such stars burn at the perfect temperature and help the planets around them gain an iron core and become Earth-like. Now let's pick relatively young stars from this pile, because when they get older, they expand and either absorb the planets around them or burn them up. One last thing, let's find planets in this pile that are in the habitable zone of the star. And voila! 36 worlds may be inhabited by some unknown civilization. But we won't know for sure until we get in touch with them. You're standing on the bridge of your super modern spaceship. Today, your mission is to fly to the uncharted areas of space. You travel past beautiful nebulae, spinning pulsars, and black holes. Soon, you'll arrive at the planet where life might exist in the most unusual forms. You'll shake hands with a strange bug the size of an elephant, and maybe even establish diplomatic relations with it. This might happen in the future. For now, humanity is just trying to get farther into space. People first took to the air in 1783, when French engineers built the world's first hot air balloon. But it only rose above the ground for a third of the height of the Statue of Liberty. In 1903, the Wright brothers made the first flight in a controlled airplane. Since then, people have been reaching higher and higher. These days, modern airplanes can climb to an altitude of 8 miles. It's like 34 Empire State Buildings stacked one on top of another. In 1931, people finally got to the stratosphere. A Swiss physicist and his assistant used a hot air balloon to reach a record height of 9.8 miles above Earth's surface. They were the first people in the world to observe the curvature of the planet's horizon. 30 years later, the first person flew to space. It was Yuri Gagarin. He launched from Earth and reached a low Earth orbit in about 10 minutes. The maximum altitude of Gagarin's spacecraft was about 203 miles. That's almost like the distance from Los Angeles to Las Vegas. The first cosmonaut traveled over the night side of Earth, flew over America, and successfully landed 108 minutes later. Nowadays, the distance of 250 miles into outer space is nothing. At this altitude, the International Space Station orbits the Earth. Astronauts from all over the world stay there at all times. In 1969, Apollo 11 set a new record for the most distant flight to space. Its crew flew about 238,600 miles to the Moon and landed successfully on its surface. The mission stayed on the satellite's surface for about 21 hours. Then, the crew successfully returned home. A year later, this distance record was broken by the Apollo 13 mission. It looped around the Moon and returned to Earth. At the farthest point, the astronauts were more than 248,000 miles away from home. That's like circling the globe 11 times. It's still the longest distance people have ever traveled in space. But we intend to break that record by flying to Mars. Once every few years, Earth and Mars line up in such a way that the distance between these planets is 34 million miles. If there was a highway from Earth to Mars, it would take you about 62 years to get there by car. A trip by spaceship would take about 6 to 8 months. When we get there, humankind will become multi-planetary, and that will be a new space travel record. For now, people have to rely on different probes to gather all the necessary information. For example, the Parker Solar Probe was sent from Earth directly to the Sun. It flew a distance of 1 astronomical unit to its destination. That's about 93 million miles. The probe has already made several circles around the Sun and Venus. But the Sun's gravitational pull is so strong that the probe's speed is now more than 330,000 miles per hour. That's 13 times faster than the speed of the average rocket. Another probe, Voyager 1, holds the title of the most distant object created by people. The probe, which weighs as much as a large motorcycle, was launched in 1977. After a year of flight, it reached the asteroid belt beyond the orbit of Mars and headed toward Jupiter. The probe took several pictures of the gas giant and flew toward Saturn. After visiting all these planets, Voyager 1 set a course for interstellar space, planning to leave the solar system. By 2004, the probe had traveled about 94 distances from the Earth to the Sun. That's where you can find the boundary of the solar system, the so-called heliosphere. Here, the solar wind slows down below the speed of sound. This creates a shock wave. It nearly tore Voyager 1 apart, but luckily, the probe survived and continued on its way. In 2012, Voyager 1 finally left our solar system and is now flying toward the star Gliese 445. It's supposed to reach it in 40,000 years. Voyager 1 has a twin brother, Voyager 2. Though the second probe was launched earlier, it left the solar system 6 years later. In 300 years, Voyager 2 will reach the inner edge of the Oort cloud. This is a cluster of small asteroids and space bodies around our solar system. In 40,000 years, Voyager 2 will pass the red dwarf Ross 248. And in almost 300,000 years, the probe is supposed to come close to Sirius, the brightest star in the night sky. Perhaps the Voyagers can make contact with another civilization and pass them the message they carry on their golden discs. The discs contain greetings in 55 languages and music from different cultures and countries. There's also sounds of the ocean, bird songs, chirping of insects, and different animal sounds. There are also 116 images that may help other civilizations understand the composition of Earth's atmosphere and the structure of human DNA. Some images are just landscapes from our planet, deserts, mountains, islands, and rivers. Anyway, to make humans a multi-planetary species, we would need to go to Mars. It'd take less than a year. But if people decided to become an interstellar species, we'd have to travel to Proxima Centauri. It's the closest star to our Sun. Light from this red dwarf reaches Earth in a bit more than 4 years. But if you decided to use good old rocket engines, the journey would take you about 73,000 years. The key to long-distance travel is speed. People would need to scrap the traditional rocket engines and come up with something new. Some scientists say we might reach Proxima Centauri before the end of this century. To do that, people will create a microprobe that will be smaller than a fingernail. It'll be launched into space, and then a powerful laser beam from Earth will push the probe forward, allowing it to reach 20% of the speed of light. In this case, the probe's journey to the nearest star will take about 20 years. But even after its arrival, radio waves with the probe signal will reach Earth with a delay of 4 years. But if we could travel at the speed of light, how far would we get? Here's the Milky Way. It would take over 100,000 years to travel from one side of its spiral to the other. And if you bought a ticket to the Andromeda Galaxy, the journey would take you 2.5 million years. About 100 million years of traveling at the speed of light, and you'd leave the Virgo supercluster. All the little dots you see there are actually huge galaxies containing billions of stars. 1 billion years on the road, and you'd be in the neighboring superclusters. Now, these dots are actually superclusters with billions of galaxies. 14 billion years of traveling, and you'd reach the edge of the observable universe. This is the maximum distance Earth's telescopes can see. There are about 2 trillion galaxies within these boundaries. Each galaxy may have stars like our Sun. Around each star, there's a habitable zone, a sweet spot where water can exist in its liquid form. That gives a chance for life to appear there. People would love to find this life and make contact with it, but the distance of billions of years of traveling makes that impossible. There's a theory that people can travel billions of light years away using wormholes. Imagine that space-time is a piece of paper. Our Milky Way galaxy is on one side, and an unknown galaxy is on the other. A straight path would take billions of years. But if you fold the paper in half, these two worlds would be right next to each other, and you'll be able to get there through some kind of hole, a wormhole. It warps space-time, which can allow people to become a multi-galactic species. Some scientists say there may be wormholes inside black holes. These are the most mysterious and massive objects in the universe. They're so heavy that they can also warp the fabric of space-time. 1 minute near a black hole could be a week or a month on Earth. Perhaps if a spacecraft could withstand such a wild gravitational force and get into the heart of a black hole, it'd pop out of the other end of the wormhole. It could be somewhere in another part of our galaxy, or another galaxy, or it could be a parallel universe. The closest black hole to Earth is 1,500 light-years away. It's called the Unicorn. It weighs about the mass of 3 suns. It means the thing is very small compared to other black holes. Some of them can weigh 6.5 billion solar masses.